Hey there, tech enthusiasts. Welcome back to another deep dive into the world of technology. Have you ever cracked open your smartphone or laptop and marveled at the intricate maze of tiny components inside? It's like peering into a miniature city bustling with activity, but these components don't just magically connect themselves into a functional device. There's a hidden hero that brings them all together. Enter the unsung hero of modern electronics, the PCB, or printed circuit board. This unassuming piece of technology is the foundation upon which all our gadgets are built. These green, often overlooked boards are the backbone of pretty much every electronic device we use. From your smartphone to your laptop and even your smart fridge, PCBs are everywhere. Without them, our gadgets would be bulky, unreliable messes. Imagine a world where your phone is the size of a brick and your laptop weighs as much as a small child. Not very convenient, right? PCBs provide a stable platform for mounting and connecting electronic components. They ensure that everything stays in place and works as intended, even when you're on the go. Think of them as the nervous system of our gadgets, transmitting electrical signals and ensuring everything runs smoothly. Without PCBs, our devices would be nothing more than a collection of useless parts. From the simplest calculators to the most complex supercomputers, PCBs play a crucial role in making sure everything functions correctly. In today's world, it's hard to imagine life without our electronic devices. PCBs are essential for modern life, enabling the technology that powers our daily routines and drives innovation. So, let's dive in and explore the fascinating history and evolution of these tiny technological marvels. From their humble beginnings to their pivotal role in today's tech landscape, PCBs have come a long way. Join us as we uncover the story behind these indispensable components and appreciate the incredible engineering that goes into every single one. Before PCBs came along, electronic circuits were a bit of a nightmare. Imagine a jumbled mess of wires and components, all painstakingly connected by hand. These early circuits, known as point-to-point wiring, were bulky, unreliable and prone to errors. They were also a pain to assemble and repair. Early radios, telephones and other electronic devices relied on this cumbersome method. It's hard to believe now, but these devices were once considered cutting-edge technology. However, as electronics became more complex and the demand for smaller, more reliable devices grew, it was clear that a new approach was needed. The stage was set for a revolution in electronics. Enter Paul Eisler, an Austrian engineer who would change the world of electronics forever. Born in Vienna in 1907, Eisler was a visionary with a passion for innovation. His journey would lead him to create one of the most transformative technologies in modern electronics. In the 1930s, while working on a radio set, Eisler had a stroke of genius. At the time, radios were complex and cumbersome, filled with a tangle of wires and components. Eisler saw an opportunity to revolutionize this. He envisioned a way to simplify circuit design by printing conductive pathways directly onto an insulating board. This idea was not just about reducing clutter, it was about creating a more reliable and efficient way to build electronic circuits. This groundbreaking idea would become the printed circuit board, or PCB. The concept was revolutionary, allowing for more compact and durable electronic devices. Eisler's early PCBs were rudimentary compared to the sophisticated boards we use today. They were simple, single-layer designs, but they laid the foundation for the multi-layered, highly complex PCBs that power our modern devices. However, they proved the concept worked. These early prototypes demonstrated that circuits could be printed, not wired, and still function effectively. The military quickly recognized the potential of PCBs, especially during World War II. The need for reliable and compact electronic components was critical, and PCBs offered a perfect solution. They used them in proximity fuses for bombs, a critical technology that significantly impacted the war's outcome. These fuses allowed bombs to detonate at the optimal moment, increasing their effectiveness. This military adoption would prove to be a turning point for PCB technology. The success of PCBs in military applications demonstrated their reliability and versatility, paving the way for their widespread use in consumer electronics, telecommunications, and beyond. Paul Eisler's invention had truly changed the world. After the war, PCBs began to transition from military applications to consumer products. The 1950s witnessed the rise of the transistor, another game changer in electronics. Transistors were much smaller and more efficient than bulky vacuum tubes, and they were a perfect fit for PCBs. As transistors shrank the size of electronic components, PCBs could be made smaller and more complex. This miniaturization opened up a world of possibilities for consumer electronics. Radios became pocket-sized, televisions slimmed down, and the first computers emerged, all thanks to the humble PCB. The world was starting to shrink, and PCBs were leading the charge. Section 5, Building Up, the multi-layer revolution. The 1960s and 1970s saw another major leap forward in PCB technology, the advent of multi-layer boards. Instead of just a single layer of conductive pathways, engineers began stacking multiple layers on top of each other, interconnected by tiny vias, those vertical conducting holes. This innovation dramatically increased the circuit density that could be achieved within a given area. Multi-layer PCBs were a game-changer for complex electronics like computers and aerospace equipment. They allowed for more powerful and compact devices. The first microprocessors, the brains of modern computers, relied heavily on multi-layer PCBs. Without them, the personal computer revolution might never have happened. Shrinking tech, expanding possibilities, surface mount technology. Transformative world of surface mount technology, a pivotal advancement in the realm of electronics. In the 1980s and 1990s, a new technology emerged that would further revolutionize PCB design, surface mount technology, or SMT. This era marked a significant shift in how electronic components were assembled, leading to more efficient and compact designs. Prior to SMT, components were inserted through holes drilled in the PCB and soldered on the other side. This method, known as through-hole technology, was labor-intensive and limited the density of components on the board. SMT, however, mounts components directly onto the surface of the PCB, eliminating the need for through-hole drilling. This innovation not only streamlined the manufacturing process but also opened up new possibilities for electronic design. SMT offered several advantages. It allowed for smaller components and much higher component density. This meant that more components could be placed on a single board, enhancing the functionality and complexity of electronic devices without increasing their size. This meant even smaller and more powerful devices. The miniaturization of components led to the development of compact gadgets that were previously unimaginable. From smartphones to wearable technology, SMT has been a key enabler of modern electronics. SMT also automated the assembly process, making PCB production faster and more cost-effective. The use of automated machines reduced human error and increased production speed, allowing manufacturers to meet the growing demand for electronic devices. SMT became the dominant method for PCB assembly and paved the way for the incredible miniaturization we see in electronics today. The impact of SMT on the electronics industry cannot be overstated. It has enabled the creation of high-performance, reliable, and compact devices that have transformed our daily lives. From the smallest sensors to the most complex computing systems, SMT continues to drive innovation and efficiency in electronic manufacturing. PCBs in our pockets. The heart of modern devices. Today, PCBs are more ubiquitous than ever. They're the beating heart of virtually every electronic device we use. Our smartphones, tablets, laptops, and even our cars rely on sophisticated PCBs to function. These boards have become incredibly complex, with multiple layers, high-density interconnects, and advanced materials. Take a look around you. From the smart speaker playing your favorite music to the fitness tracker on your wrist, PCBs are everywhere. They enable the Internet of Things, connecting our devices and homes in a vast network. They're essential for robotics, medical devices, and countless other industries. The world as we know it wouldn't exist without PCBs. The future of PCBs, 3D printing and beyond. So, what does the future hold for PCBs? As with all technology, innovation never stops. One exciting development is the use of 3D printing to create PCBs. This technology allows for rapid prototyping and the creation of complex three-dimensional PCBs with embedded components. Nanotechnology is also poised to play a major role in the future of PCBs. Imagine circuits built at the atomic level, enabling even smaller and more powerful devices. Researchers are also exploring the use of biocompatible materials for PCBs, opening up possibilities for implantable medical devices and other exciting applications. The future of PCBs is bright, and these advancements promise to further revolutionize the world of electronics. Hit that like button, subscribe, and stay informed.